Okay, so back to this ShiftOut relay conundrum. So I went online uh, just to kind of refresh my memory about how these boards are actually set up, how they're wired. And in the comments of one, I just happened to notice that some guy said, "Hey, by the way, my relay board happened to have the silk screening of the NC and O ports or pins reversed." So I was wondering if that was the case with my board. So basically, on every relay, you have a COM port, which is basically your power coming in, and then you have two other ports. One's labeled NO and one's labeled NC. NO is normally open, and C is normally closed. Normally open means that basically the power coming into the COM would just flow automatically out the normally open, basically without your need to flip the switch on the relay. So if they're reversed, and I was intending for mine to be always on the normally open, and it was actually in fact normally closed, obviously that would explain why my motor controller board was never getting power, even when everything pointed to the fact that it should. Long story short, that is the case with my board. I discovered this in testing, but anyway, back to the ShiftOut stuff. So if you caught the last video, I was doing a bit of wiring. I just stuck with one wire just so I could kind of, as a proof of concept, make sure that what I'm trying to do works, because I don't want to do the complete wiring harness until I know how I want to wire it permanently, so that I know how long or short I need the wires to be. I basically don't want to waste the wiring and the caps and stuff. Also, it's a nuisance. So on to how it all comes together now. So everything is the same as it was before. Basically what we've got new now is this blue cable right here that you would have seen in the last wiring video. So as you can see, we've got 8 pins here, 2 sets of 4. I'm speaking of kind of from left to right here. There's actually 8 times 3. So each of these is a positive, a negative, positive ground, and then a digital pin. So all we really need is the digital. And then that digital goes over to the relay board and into whichever pin you want to control. So I basically just, like I said, using just the one wire for now, connected that to the last pin here and the last pin there, since this relay is the one of interest to us. So let's connect up the power via the USB cable on my laptop and look at some code. Okay, so before I actually connect the USB cable, I wanted to show you guys this. So this is just some example code that I pulled off the web. Basically, I don't want to reinvent the wheel. I want to make sure that kind of the basics work before I start messing around with it, since usually when I mess around with things, they break. What's really important for our purposes right now is these 3 values. I've commented out some previous values that I had in here, but basically you've got latch pin, clock pin, data pin. Those are the pins that we wired in on the Arduino. So you can see those 3 pins here, the 8, the 9, and the 3. So the yellow, the blue, and the red in the center of your screen. So basically, once we've got the wiring done, what we really only care about at that point, excuse the shakiness, is this value here, where you see my cursor or my finger now. So basically all we want to communicate is a value such as these. I just found this online here again. So basically this is how we send the values. Either they're all 1s, some combination of 1s and 0s, or all 0s is all off. So basically if we wanted to send a command to turn off all the relays, we'd send all zeros. If we wanted them all on, we said all ones, or some combination thereof. So let's connect up the USB port and give it a go. So I've just plugged in the USB cable, and you can see that the Arduino is on, and the relay board is on the light there. So all I'm going to do now is upload this new sketch to the Arduino, specifically this value here, the FF, and basically that just sends the signal of all ones, or all relays to be on, just so we don't mess around with kind of which one's which. So once I do that, we should see something happen. Fingers crossed. Okay, so I'm just going to hit the upload button, and what we should see is some lights come up on the Arduino to indicate that it's receiving the new sketch. We should see them somewhere there. And then once that goes through, there we go. There's the green light on the channel 8, the last one. Success, yay! So now if we change this to zeros instead of F's, and we re-upload the sketch. So I'm going to hit the upload button now, and what we should see is channel 8 turn off after the Arduino starts blinking, of course. There are the lights on the Arduino, and success. Awesome. So you can see that I'm all smiles. I know that this is all really simple stuff for people who are way good at this, but for me this is a minor miracle. It's been a couple years since I've done anything with this thing, and just to have this little light turn on, you have no idea. Yeah, so now that we've got that, I guess I got to figure out how to lay in the ShiftOut module permanently so that I know how to do the wiring harness. Basically, I want to have the wires as efficiently laid in as possible, so I don't want a lot of extra wire where I don't need it. It'll just add clutter, and space is at a premium. So I'll give you guys a shout back when I've gotten at least something figured out, and then I'll share that with you and go from there. Cheers!